Use the definition to find the derivative of f of x equals 1 over the square root of 4x plus 1, then evaluate f prime of 2. First thing to do is write down the definition of the derivative. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x divided by h. The next thing to do is to formulate f of x plus h, which means to take f of x, 1 over the square root of 4x plus 1, and replace each x with an x plus h in parentheses. 1 over the square root of 4x plus h plus 1. We're going to subtract from this f of x, 1 over the square root of 4x plus 1, and then all of this is divided by h. This is a 0 over 0 indeterminate form and will continue to be until we can factor an h out of the numerator to cancel with that h in the denominator. We don't have the ability to do that just yet. What we do have in the numerator is fractions subtracting each other. We will need to combine those by a common denominator. In order to make that common denominator a little bit easier, I'm going to distribute the 4 in the denominator of the first fraction in the numerator. So it becomes 1 over the square root of 4x plus 4h plus 1 I'll leave the second one the way it is, and all this is divided by h. Our next step is to be finding the common denominator between those two fractions. We have the denominator of root 4x plus 4h plus 1 and a denominator of the root of 4x plus 1. The common denominator will be those two roots multiplying each other. Which means that we have to take that first fraction, 1 over the root of 4x plus 4h plus 1, and multiply it by root 4x plus 1 over itself. And we need to take the negative 1 over the root of 4x plus 1 and multiply it by the root of 4x plus 4h plus 1 over itself to get the common denominator between the two fractions. And then all of this is divided by h. Now the first fraction, 1 times the square root of 4x plus 1, will be the square root of 4x plus 1 minus the second fraction, which is 1 times the square root of 4x plus 4h plus 1, all over that common denominator of the two, which is the multiplication of two roots, therefore it can be written under the same root. A 4x plus 1, I'll write that one first, and then a 4x plus a 4h plus 1. They're now over a common denominator. The next thing to do, since we have a fraction in the numerator, is to take the fraction in the denominator, reciprocate, and multiply it. It's not a fraction right now, but it can be made a fraction by putting it over 1. And now we will reciprocate and multiply. So I'll just write the entire numerator fraction exactly as we see it. Reciprocate the denominator fraction, which means it'll become a 1 over an h, and then we multiply those. So that will give us limit as h goes to 0 of the numerator, 4x plus 1 minus the 4x plus 4h plus 1, each of those under roots, over the denominator will be the multiplication of h times the root, so I will just write the h in the front. It's not under a root, and it will not end up under the root with the others. Now we still have the 0 over 0 indeterminate form, and we will continue to have that until we can factor an h out of the numerator to cancel with that h in the denominator. And we still don't have the ability to do that because h in the numerator is stuck in a root, the second root specifically, that is combined by addition or subtraction to at least one other term, which means we have a root combination, which means we need to make use of the root conjugate. We're now going to multiply the numerator and denominator by the root conjugate of the numerator. The root conjugate will be those same terms, but opposite sign between them. We're going to put it over itself, a form of 1, so that when we multiply, we don't change the value, just the look. And that's our next step, is to multiply times that root conjugate. Now when we multiply the numerators, those are root conjugates. We're going to FOIL that out first. Root 4x plus 1 times root 4x plus 1 will just be a 4x plus 1. Outside, we will have a positive root of 4x plus 1 times 4x plus 4h plus 1. Inside, we will have a negative root of 4x plus 1 times 4x plus 4h plus 1. And then last, we'll have a negative root of 4x plus 4h plus 1 times a positive root of 4x plus 4h plus 1, which will be a negative of 4x plus 4h plus 1. It's the negative of that, so we have to distribute that negative sign. All of this over the denominator. After FOILing out a root conjugate, the outside and inside terms are equal value opposite sign, and so they will cancel. The denominator we're not going to FOIL out, but leave exactly as we see it. So we have h times this root times the sum of these roots. But our goal remains the same. We need to get an h to factor from the numerator to cancel with that h that is in the denominator. We still have to have that happen. But nicely, after having multiplied by the root conjugate, the numerator is now going to be 4x plus 1, and then we want to distribute the minus sign on this expression here. So we're going to do that, and that will give us a negative 4x, a negative 4h, and a negative 1. And all of this is over the same denominator. We haven't done anything with that just yet. there are several terms in the numerator, and we can combine them together. Now, any terms that don't have an h should cancel at this point, and that'll help check your work to make sure you're doing the correct work here. So we have a positive 4x and a negative 4x. Those cancel, and a positive 1 and a negative 1. Those cancel, and the only terms that have an h in them in some way remain. We just have that negative 4h in the numerator and nothing else. And that means we're going to be able to cancel that h that's in the numerator, multiplying that negative 4 with the h that's in the denominator, at which point we can plug a 0 in for the remaining h's, and that should give us our derivative. So let's go ahead and cancel these h's out. And we no longer have the 0 over 0 indeterminate form. And we can plug a 0 in for any remaining h's. There is no h's in the numerator. In the denominator, we will have the square root of 4x plus 1 times another 4x plus 1 when h is a 0. And we will have the square root of 4x plus 1 plus another square root of 4x plus 1, which means we have a negative 4 over the square root of 4x plus 1 squared times 2 square root of 4x plus 1 after we add the 2 together. And so we have negative 4 divided by, down the denominator, we can multiply everything together. We have 2, and then we can put those roots together, and since they both contain 4x plus 1, one is squared and one's to the first power, it becomes cubed. The negative 4 and the 2 can slightly cancel down by a factor of 2, so we have negative 2 over. And then in the denominator we have the square root of 4x plus 1 cubed. Another way to write that, the square root of a cube means 3/2 power. That means to take the square root and cube it, or cube it and take the square root. You can go either order with that, but there's our derivative. The last thing to do is to evaluate f prime of 2. So let's go ahead and do that. F prime of 2 will be a negative 2 divided by a 4 times a 2 plus 1 to the 3/2, which is a negative 2 divided by 4 times 2 is 8 plus 1 is 9. So we have 9 to the 3/2. Now what the 3/2 means is to take the square root and cube it, or cube it first and then take the square root. You can go either order, but it'll be easier to take the square root first and then cube it. The square root of 9 is a 3, so this is going to be a negative 2 over 3 cubed, or negative 2 over 27.